everybody, it's Miss Kim from Naturally Stem. So good to see you guys again today. I'm excited to be here because I want to talk about wild chemistry. Do you guys know that chemistry happens in nature naturally all the time and in very many different ways? So we know that chemistry is simply two substances put together. When they're mixed up, they will create a new substance. A simple way for me to show you that is, I have a glass of milk. I have some chocolate syrup. Two different substances, milk, chocolate syrup. Now what do you think I'm going to do? I'm going to mix them together. Whoops, missed the glass and everything. It's quite alright, right? Just look at it right there. I'm going to mix it up. And what did I do, my friends? I created a new substance called chocolate milk. Some of my favorite chemistry ever. So as you can see, chemistry happens very simply sometimes, just like chocolate milk, or it can happen very complex. Takes a lot of things to make it happen. And so let's just look at a few examples of how nature uses chemistry and see what's going on out there. Take, for instance, this guy right here. Who is he? Just think about it. He's got that white stripe down his back all the way down his tail, and when they're bright like that, sometimes that's a warning sign to say, hey, I'm bright, I don't care, you might not want to mess with me, I'm small, but there's a reason I'm not scared of you. So what do you think that could be? Number one, who is he? That's right, my friends, this is a skunk, just like Pepe Le Pew, right? Pepe Le Pew stinks, right? That's exactly what they are. And they do that, they get stinky for defense mechanism, okay? But how does that stink happen? What do they do? Well, what happens is, of course they have to turn around, right? And they spray you from behind, from the little rump, okay? They have two glands on each side of their little backside. And there's some chemicals in there. And when you guys or somebody, an animal or whatever, walks up on them, scares them, they will give you warnings before they spray you because they don't like that stinky smell themselves. Okay, so remember that. I'll tell you what they are in a minute. But if they have to, they're going to turn around, they're going to raise their tail, and they're going to let their chemical reactions work. They have glands on each side and they have little tubes, and they're going to spray, and that spray is going to come out, and that chemical reaction is going to hit you in the face, and it's going to make you or the animal terribly, terribly sick. It's not a good smell. It does induce vomiting and stomach cramps, and it's not a good thing. If you don't want to see that chemical reaction from a skunk, pay attention if you've ever seen one. They're going to give you some warning signs, and I'm going to show you really quickly before we move on, just so you have some knowledge of that. If you come along and you see a skunk and you want to pet him, because they are cute, they are some of the cutest things you ever saw, but I wouldn't advise trying to pet them because they don't like that. They're going to scare them. So the first thing they're going to do is they're going to take their mouth and they're going to hiss at you. And if you was here with me, friends, I'd be asking you to do this with me so we could all be skunks together. If you didn't listen to the hissing, they're going to take their front paws and they're just going to start patting them on the back. And they're going to hiss. They're going to try to make themselves louder and bigger and scarier to you so you guys run away. If that doesn't happen, then they will turn around. They will go onto a handstand, that tail comes up. And once that tail has to come up, my friends, guess what? That chemical reaction is going to happen and somebody's going to get sprayed. Okay? You cannot run far enough or fast enough to get away from the skunk smell. They're going to spray you. You just can't avoid it. And if you've ever heard that you can take tomato baths and things like that, I haven't found anything that has actually worked, and I've been sprayed a couple of times. My dog has been sprayed, and it just takes a lot of soap and water and about 2 weeks to really go away. So remember that. There are a lot of reasons that there are chemical reactions in nature. Wasps and bees are perfect examples, but I really love to talk about wasps because there are very many different kinds and they do different things. They do it in different ways. So you see I have a couple of different examples of wasps' nests, and then these are how they protect their babies. Okay, so we're going to start with these right here. This is a paper wasp nest, and if I said paper, listen, it is very, very soft. Okay, I'm just going to take a little piece and show you. When I say paper, my friends, that's exactly what I mean. It feels like paper, and it's very fragile. Okay. But what's really awesome about these, this is a chemical reaction, and this is their nest. So the queen bee, when it's time in the spring, she will come out and she will create the nest with these little chambers to lay her eggs. What she does, though, is really cool. She finds bark off a tree, and she will put it in her mouth. She bites stop, puts it in her mouth, and she chews and chews and chews. And she chews for a good long while until it becomes pulp, right? And the chemical reaction between that wood and her spit, or the saliva in her mouth, creates this material, and it allows her to build this nest. Okay, so from her spit and bark, that is how that works. This is a mud dauber nest. So when I say mud daubers, what's the first thing you think of? Mud, exactly. And that happens the same way. They stick it in their mouth, and the chemical reaction of the spit, one substance, and the dirt, substance number 2, they mix it together, and they create this gooey substance that they can form however they want, and they will form those holes in there, and again, that's where they lay their eggs. But it's all done with spit. How gross but cool is that? I love it. I love it. These are egg casings of oak gall wasp. I have to say that really slowly because sometimes I get tongue-tied. It's really cool. So this is what it looks like when you guys notice them in nature. They come in different sizes, kind of different forms. This is a different type of oak gall, but that is what that is. What happens is Mama Wasp comes along and she sits on a leaf. I took this leaf from one of my sister's houseplants. Don't tell her. But they come along and they land on a leaf. They take that long ovipositor, it looks like a long tail at the end of their backside, and they will find some place that they like on the leaf. A lot of the times it's that mid-rib or that vein right there. But they will inject a chemical into this leaf, and then the leaf actually folds up on itself. It's called a modified leaf. Folds up on itself and eventually becomes this right here. Then the egg is inside here, and it stays very nice and very protected because on the inside, and I have one here, it's just very fibrous, okay? Very fibrous. So that allows a cushion in there for the egg to be well protected for as long as it needs to be in there. And then when it's ready, it will drill a hole, and it's actually, the wasp is a really tiny wasp. So actually the hole is so tiny that sometimes I have a hard enough time finding it, but it's right here where my finger is, and it's small as a little pinprick. So it's just the tiniest little hole. So, but it's all done with chemical reactions. The chemical of the wasp, whatever she puts in there, and then the substance of the leaf allows that to modify. And if you find these out in the woods, look at them very, very closely, and you will actually see the veins that used to be the leaf. So it's really, really awesome. I love that. Bees will do the same thing. This is a honeycomb. So bees make their honeycombs in about the same fashion as our wasps do. So as you can see, as I'm talking, chemical reactions happen for a couple of different reasons. They happen for to help raise their babies. These are all to shelter and to help raise their babies. The skunk, he had his chemical reactions for a defense. I have my friend right here. He is a spider, right? Now my friend, he's a Halloween decoration. I just modified him a little bit. We don't have spiders this big. Thank goodness, we'd all be scared, wouldn't we? But we have spiders, and they have a couple of different adaptations of chemicals, which are really cool. The first one is they have their little spinnerets back here. So this is where the silk comes out of the spider. And when they create that silk, that's a chemical reaction within their bodies. And then that silk, they create that silk, and that silk comes out. What's really cool is we as humans have been studying chemical reactions in nature for a long, long time. And how can we take advantage and use those type of things? And we're learning that we can use spider silk. It's one of the strongest materials around, so we're learning how to use spider silk to our advantage. Things like that, humans do that all the time. But that's a chemical reaction when they make their web, their silk. But also they have to have a chemical reaction when they do what? Yeah, when they hunt their prey, right? When they catch their prey, what do? Well, let me show you. So a spider, he will have two pedipalp eyes. They're little mandible looking things like this, and then he's going to have two fangs in his mouth, okay? So these mandibles, they help hold an insect once they catch him. So I'm going to use, this is a packing peanut. You know, you use that when you pack stuff to mail it to different places. That's what this is, okay? So the spider will catch the insect. If it's caught up in his web, or he's a funnel spider, he is a predator, so he'll reach out and grab him. So he'll have the insect, and he will use his mandibles to help hold it in place. Then he's going to take his fangs. Okay, this is my fang. This is how I help show people. So this is my fang, and it has venom. It's really water, but for in this instance, it's my venom. And I only have two hands, so I only have one fang and one insect. Okay, so I have my fang, and I have an insect. They bite that insect, and they inject their chemical into it. And what happens? And if you could tell, I am melting from the inside. My insect melts from the inside. So when that venom hits the inside of those insects, all of the insides, the bones, the heart, the liver, the kidneys, all of that stuff liquefies. So when the substance venom hits the other substances inside that body, mixes up, all of that stuff melts, and then my spider takes this awesome little hollow tongue, and he just slurps out the insides just like a Slurpee. How cool, awesome is that? That is one of my favorite ways to show chemistry. Spiders are great. They are a lot of fun. Now we have the brown recluse and the black widow are the two spiders in Oklahoma that we want to watch out for. So you might go research those two, black widow, brown recluse, and see what kind of chemical venom they have. They are very, very cool. So spiders, they use chemical reactions all the time. Of course, venomous snakes do as well. Venomous snakes are the ones that have the fangs, okay? Venomous snakes have fangs, where non-venomous, they have teeth in their mouth, but they do not have those fangs that's going to bite into you and inject you with venom. So these guys have that awesome chemical reaction in their venom as well. So that's what immobilizes their prey animal so they can eat it. So these guys have chemical reactions in nature for to build their spider webs and to eat. So and to defend. So if they have to defend themselves, they will also use the venom, but they don't want to, but they will do that. So many different reasons for chemical reactions to be happening in nature. A couple more of these are different types of fungus or mushrooms. Mr. Spider, I'm going to move you over here, my friend. Thank you. Okay, so we have different types of fungus. Fungus are those things that you see on trees and around dead things, right? That's exactly what these guys do. Fungus or mushrooms are very, very important in our ecosystem. These guys are one of the most important things we need out there. We need decomposers. Wonderful word. You guys know what a decomposer is? Exactly. It is something that breaks down organic matter, like dead trees and plants and things like that, and turns them back into soil. It takes a while for that to happen, years, but eventually that big tree that dies and falls over, you're going to see fungus of different types appear on it, and through a chemical reaction, once they attach to that dead tree, a chemical reaction happens, and these things are what breaks that big tree down in years and years and years, and breaks it back down into the nutrient-rich soil that we need so desperately to grow our crops and to grow those green plants and trees that, what do they do for us? Exactly, they create the oxygen that we need to breathe. So these guys are one of the most important things that we have in nature, and their chemical reaction helps keep us alive. So yay, fungus! I love it. Okay, let's talk about, have you ever seen something glow in the dark? Have you ever seen it glow at you at nighttime? Fireflies, exactly, lightning bugs. Lightning bugs, so certain cave animals that live in the darkest, blackest, pitch black part of the cave. Some types of fungus, some ocean animals, they all glow in the dark, don't they? They have special chemicals and chemical reactions inside their body that will create a light, and that's called bioluminescence. And that is when they create their own light from inside their bodies. And that is, again, done by a really cool chemical reaction. And I have my flashlight here, and we're talking about fireflies, and what's really cool is there are many, many species of fireflies in the world. I cannot remember how many different species, but there's a lot. And those fireflies, each species has its own signal. What I mean by that is one firefly might have a short, long, short, long. Okay. Another firefly might have a long, signal. They all have different types of signals, and that allows them to be able to tell who is who when they're all flying around. Now, the lightning bugs, when they're flying around and they're lightening up, they are searching for mates. So that is the reason that they're lighting up. And what is really cool about this is sometimes the females will fly all the way down to the ground, and they will not do their species signal. They will do another species signal to track that male. Now, why do you think she's doing that? Some of you guys got it on the nose. So smart. Fireflies are one of those insects that needs a blood meal after so she can have her eggs. So a blood meal will help her be able to lay the eggs. So once she has mated, she will fly down to the ground. She will signal a different signal to a different species of firefly. The male will see that of a different species, fly down. She grabs him and eats him. So she is actually a cannibal. So some firefly species are cannibalistic because they will eat the males of different types of fireflies, so she can help her eggs fertilize and do what they need to do. So how cool is that? Would you guys like to make a firefly with me right now? Awesome. I'm glad you guys said that, because that's what we're going to do. You guys are just going to need a water bottle with a lid on it. This is a great way to recycle water bottles when you're done with them as well, instead of just having to throw them away. A great way to recycle, which is something I am all about. We are going to have a bottle half full of water, a yellow highlighter. The newer, the better, because if it's brand new, it's still fresh ink. The more that you've used it, the more it dries up. So the newer yellow highlighter, the better. Scissors, I just have a small pair today. Pliers. Now, you can have needle-nose pliers. They're going to work the best because you're going to have to pull this thing off. But I'm going to suggest to my younger friends to please have an older sibling or an adult do this part for you, so there's simply no injuries. I don't want anybody to ever be hurt when we're doing funtivities together. And then you're going to need tape. Here's what I'm going to do. I'm going to move everything. I have a habit of sticking everything right in the middle, don't I? Water, tape, highlighter, pliers, scissors, and you can draw a face and a little abdomen, and then our little bottle is going to make our third part of the body, and 4 wings, because all insects have 4 wings and 3 body parts. Now, I've drawn this. You guys are more than welcome to draw your own, but I also have this template in black and white on my Facebook site. So you can simply go to facebook.com/naturally stem and just download this template if you want to. I have it in black and white, so you could just download it, print it, color it, cut it out. We'll be ready to go. Okay? So whatever you have. So what we're going to do first is we're going to take our bottle and we're going to fill it half full of water if you haven't done so. We're going to, this is where it gets tricky, and this is where I ask that you get your adult or older sibling to help you. Now, I've already worked this one out a little bit, but I will show you. So this is one that I haven't done. It's going to take just a minute to get that out. So you just work it from all 4 sides, a little at a time. I've already done that and been able to pop mine out. Now just let this cartridge, the ink cartridge from inside, out. Now you're going to get your hands a little bit yellow, but it just comes off with water, so no problem. And what I do is I just take my scissors and I cut the outer hard layer of the ink cartridge. And that just helps the color come out, I think, a little bit better. Okay, and so there's going to be a little fiber in there, right? So then we're just going to drop it right into the bottle. Now I've had my substance of the yellow highlighter, this chemical stuff in there, and it is now mixing with my water. We're going to shake it up. We're going to let it set aside, and we're going to let that chemical reaction happen. So the chemical reaction of the highlighter and the water is starting to happen. Okay. While they're doing that, we're going to cut this out. Okay. So I'm going to cut this out really quickly. Okay. We got our little guy cut out right here. I'm not the best cutter, but that's okay. And I did one earlier before I started to make sure that we got a good glow going. And look at that. Look at that. But the one that we just did is going okay in itself. But this one, look how awesome he's already glowing. So what we're going to do, friends, is just simply take our friend. I got a piece of tape, and I'm just going to fold it up just like that. And I'm going to tape it right in the middle of him. And I'm going to tape it right here. And there you go. A glow-in-the-dark firefly. So give it about 10 minutes. Go find the darkest place that you can find and see how well your firefly glows. I love it. I appreciate you guys being with me again today. Please go to my Facebook that I just told you where to go to, facebook.com/naturallystem, and tell me how your guys' fireflies went. Take a picture, show them to me. I love to see them glowing. So I hope you post on my Facebook and let me see some of the awesome fireflies that you guys made. I will see you later. Please grab your adult and go enjoy your naturehood. See you later, friends. Bye.